Well, we had a couple of technical difficulties. So let's finish the review sheet here. All right, we're going to look for the mass of a satellite if the force, the gravitational force, is 10,500 newtons. So Fg is 10,500 newtons. It has a velocity of 1,025 meters per second. And the distance from the center of the Earth, this is always my radius, is 6.41 times 10 to the 6 meters. Now, in this case, I know FC must equal FG, and I actually have that number here. So FC is equal to FG, and FC is mv squared over r. All right, so I've just made that substitution right there, that FC is mv squared over r. I need to do a little bit of algebra here. I need to solve for the mass. To solve for the mass, first thing I'm going to do is get rid of my denominator, so I'm going to get rid of my r's. So r Fg is mv squared. I'm going to continue solving for m. To get rid of m, I need to get rid of v squared, so I divide through by it. So the mass in this case is, let's see, those cancel, r Fg divided by v squared. And I'm going to plug this thing in up here. The radius is 6.41 times 10 to the 6 meters. The force of gravity is 10,500 newtons. And the velocity, now the velocity is squared. So this is 1025 squared. So what you want to do on this is multiply straight across the numerator. So 6.41 times 10 to the 6 times 10,500 gives me, let's see, 6.7305 times 10 to the 10th. That's a 10. All right, and this is going to be divided by 1025 squared. Let's see, 1025 squared, I'm going to write this out, is 1050,625. So 6.7305 times 10 to the 10 divided by 1,050,625 gives me 64,061.9 kilograms. We certainly have enough sig figs here. Realistically, if we were looking at sig figs, and we're really not, the most you could have is 3. So if I were picky, this would be 64100 kilograms. But this is fine. Just don't give me everything in your calculator. Now, what is Fg of the Earth on the moon? Okay, we have to come to our standards chart. What do we need? We want to know the force of attraction between the moon and the Earth. All right, so we need the mass of the Earth, the mass of the moon, and the distance between the Earth and the moon. Let's see. The mass of the Earth is 5.98 times 10 to the 24th kilograms. The mass of the moon is 7.35 times 10 to the 22nd kilograms. And r, the distance between the Earth and the moon, is 3.84 times 10 to the 8th meters. So the attractive force between them is going to be Fg is big G, mass of the Earth, mass of the moon, divided by the radius between them squared. Remember, big G is 6.67 times 10 to the negative 11 times the mass of the Earth is 5.98 times 10 to the 24th kilograms times the mass of the moon, which is 7.35 times 10 to the 22nd kilograms. This whole big ugly thing is going to be divided by the radius squared. So this is 3.84 times 10 to the 8th squared. So let's multiply straight across. 6.67 times 10 to the negative 11 times 5.98 times 10 to the 24th times 7.35 times 10 to the 22. Oh my gosh, this is 2.931661 times 10 to the 37th. All right, divided by 3.84 times 10 to the 8th. And when you square that, you get, let's see, 1.47. Did I do that right? Times 10 to the 17th. So let's see if I did that. 2.931661 times 10 to the 37th divided by 1.47. I'm getting a very different number. What did I do wrong? Let's see. 3.84 times 10 to the 8th. I've got the correct speed. Mass of the Earth, mass of the Moon. Let me rerun my numbers. 6.67 times 10 to the negative 11th times the mass of the Earth, which is 5.98 times 10 to the 24th, times the mass of the Moon, which is 7.35 times 10 to the 22, gives me 2.93665 times 10 to the 37th. Okay, and then divide that by the radius, which is 3.84 times 10 to the 8th. Ah, I know what the problem is. This answer is wrong, folks. Imagine that. I did that without squaring my denominator. Whoops, imagine, teachers make mistakes all the time. The actual answer is 1.988 times 10 to the 20th newtons. Now, if you go through and you do a problem and your answer differs from mine, then do exactly what I just did. Rerun all your numbers. Recheck to make sure you have the correct masses. If you're still getting the wrong answer, it could be my fault. Now, 24. 2 tennis balls weigh 1.64 kilograms. So mass 1 equals mass 2 equals 1.64 kilograms. Their centers are 0.02 meters apart. So R is 0.020 meters. So we have this situation right here. Solve for the gravitational force between them. Fg is big G, m1, m2 divided by r squared. All right, so this is 6.67 times 10 to the negative 11. M1 is 1.64. M2 is 1.64. You can just put a square there, but hey, that's all right. This will work. 0.020 squared. Now, given that last fiasco with the last problem, we're definitely going to rerun these numbers. 6.67 times 10 to the negative 11 times 1.64 times 1.64 gives me, let's see, find my pen, 1.79399632 times 10 to the negative 10th divided by, let's see, what is 0.02 squared? This is 4 times 10 to the negative 4th. So 1.79399632 times 10 to the negative 10th divided by 4 times 10 to the negative 4th gives me, oh, at least I got this one right, 4.4849, that's 5, that's close, times 10 to the negative 7 newtons. I feel slightly redeemed. Two balls have their centers of mass 2 meters apart. One has a mass of 5 kilograms. The other has a mass of 8. What's the gravitational force between them? Okay, I don't have a lot of room, so I'm just going to do my givens up here. M1, M2, R. So FG is G M1 M2 divided by R squared. Pen, acting bad. All right, so this is equal to G is 6.67 times 10 to the negative 11. M1 is 5 kilograms. M2 is 8 kilograms. And this is divided by, what was our distance? 2 squared. So 6.67 times 10 to the negative 11 times 5 times 8 gives me, let's see, 2.668 times 10 to the negative 9. Divide this by 2 squared is 4. And I get 6.67 times 10 to the negative 10 newtons. Now, if the distance is cut in half, what's the gravitational force between them? I can start all over and use a distance of 1 meter, but let's not. Fg prime equals, watch what happens, G M1 M2 divided by R squared. If I cut the distance in half, okay, so I'm going to put a 1/2 here, and because it's attached to the R, it's going to be squared. This becomes, let's see, I'm going to put all this out here, G M1 M2 divided by R squared. Now, 1 over 1/2 becomes 1 over 4. And 1 over 4 in a denominator is 4 times. So this becomes 4 times Fg, or 4 times 6.67 times 10 to the negative 10th, or 2.668 times 10 to the negative 9 newtons. You can go back and do it this way if this way is a little confusing. All right. What is force of gravity acting on a 500 kilogram spacecraft which orbits 3 Earth radii from the Earth's center? All right, so let's see. Here's the Earth, and here's the spacecraft at 3R. Let's see. What's the force of gravity? So I have the mass of the satellite is 500 kilograms. And let's see, what is the radius? The radius is 3 times the radius of the Earth. What's the radius of the Earth? 6.38 times 10 to the 6 meters. So let's go on and do this. 3 times 6.38 times 10 to the 6 gives me, okay, 1.914 times 10. Now my calculator didn't put it in scientific notation, so I've got to count. 1, 2, oh, can't see it. 1, 2, 3, 4, 5, 6, 7. Okay, times 10 to the 7 meters. All right, we're looking for the force of gravity. Let's see. Fg equals big G, mass of the satellite, mass of the Earth, divided by the radius from the Earth squared. So according to this, I'm going to need the mass of the Earth as well. So the mass of the Earth is 5.98 times 10 to the 24th kilograms. So the force of gravity that this guy feels is equal to 6.67 times 10 to the negative 11 meters squared per kilogram squared times the mass of the satellite, which is 5,000 kilograms, times the mass of the Earth, which is 5.98, times 10 to the 24th kilograms, divided by his radius from the center of the Earth, squared, which is 1.914, times 10 to the 7th, squared. Go ahead and write these numbers out. Now, I already got 1.914 times 10 to the 7th in my calculator, so I'm going to go on and square that. And I get that this is 3.663396 times 10 to the 14th. I make a lot of mistakes, folks, and this is one way I can cut down on my mistakes, is to not retype things in. So now I'm going to multiply all this mess straight across. 6.67 times 10 to the negative 11 times 5,000 times 5.98 times 10 to the 24th gives me, oh, where's my pen? 1.9943 times 10 to the 18th. So when I divide those two numbers out, 1.99 to the times 10 to the 18th divided by 3.663396 times 10 to the 14, I get 5443.9 newtons. Yes,